Hey everyone, thanks for joining me. Today I'm happy to announce Bitbybit version 1, right? It's the first version that I've released. Okay, just joking, right? There are already 99 versions of Bitbybit that are on NPM, and the 99th one is version 1.0.0. So this is the latest one. It took me a while to get here, but I'm really happy that the project has evolved to reach this phase, and now it's already used in various kinds of projects and applications that just run bit by bit in production. So I thought, why not give this release an official number, version 1.0.0, so that it doesn't look like a beta project, right? I think, in fact, it's out of beta for quite some time. It's definitely quite stable. It still used some older technologies that I'm happy to have replaced in version 1. Part of that story is, of course, the migration to OpenCascade version 8.0. It was released last week by OpenCascade. So before that, they were on a release candidate version, and I waited till they finished all the updates, and now I was also happy to just release the new version 1. Another thing that was introduced in Bitbybit version 1 is BabylonJS 9. The latest ThreeJS version, 184th one, if I remember, and the new PlayCanvas version 2. So all the packages that I'm using in the project have been bumped up. Everything looks stable, unit tests pass, right? So it's ready for use. Another thing that was released in version 1 is Bitbybit cad-cloud. You may have seen that already. I had some videos prepared for it, some introductions. But in this video, we will walk through that too. So usually I just talk about one thing, but this time I will walk through many aspects of Bitbybit platform. The video itself will be meant more for developers and enterprise customers to introduce the architectural concepts of the platform, various kinds of solutions and integration pathways, how Bitbybit can be used to create your own 3D configurators on your own websites, right? So there are quite a few steps to achieve that, but this is the ultimate goal of Bitbybit users, right? No matter where you start, you may be a computational designer, you may be a programmer, you may be a business owner, wherever you come from, Bitbybit can be used and is used mostly to create 3D configurators and experiences on your own websites. It might be that you're still learning and you're using our visual programming editors like Rete and Blockly. Maybe you're an educator who's using those tools, but the ultimate goal of all of the users of Bitbybit is to have 3D CAD experiences on their websites. And we will walk through the map of the platform. I've prepared a nice diagram which explains how everything is connected and how you can leverage various aspects of the platform, various parts of it in your own projects. So let's get started. I'm quite excited. Without further ado, let's dive in. Okay, so if you want to learn more about version 1, you must check this blog post, new OCCT 8 kernel, some new features like step assembly support. Of course, there's mention of the CAD cloud. And there's a lot of information about everything here that is related to this release. But we will start with this map that I mentioned to you already. It explains really well, I think, how Bitbybit ties with your website, which parts of Bitbybit you can use. And it also shows you several options of how you can integrate Bitbybit into your own websites. Okay, so I opened this image, and on the top here we see it says your website, right? So usually websites consist of front-end and backend, right? This is standard web architecture for any kind of website. Usually you do need front-end and backend, right? Sometimes backend is not necessary. And to be honest, so far Bitbybit was mostly using front-end technologies. Bitbybit up until version 1 was using frontend with npm packages like that. So you had already node modules, IFrame, and Bitbybit Runners. And the new part of the infrastructure is this, Bitbybit for the backend, right? We set up this Bitbybit CAD cloud infrastructure, new integration layers for the backend, but all the things that you see on the front-end side, they already existed. So if you're not familiar with Bitbybit, usually how it works on the front end, you either use React or Angular or Vue or some other framework. You choose 3D rendering engine like BabylonJS, ThreeJS, or PlayCanvas. These are all supported by Bitbybit. And you integrate Bitbybit CAD, right, through NPM. There are various ways how you can do that. So one of the ways is through node modules, and we will look into this option first. But there are other options like Bitbybit Runners, IFrame, where you directly pick up the context from Bitbybit website and render that on your website. And afterwards, we will also discuss this new backend integration. So I'll start with node modules because this is something that is very critical, I think, to understand. You see here on the bottom, we have NPM packages. These are all open source and MIT licensed packages. So our packages, our source code is licensed under MIT. Individual technologies such as BabylonJS, ThreeJS, they can have their own licensing models. OCCT, for example, is also using its own license. So Bitbybit source code gives you MIT license for itself, and the other technologies that we use may fall under different license, so you have to be aware of those things. But in general, all of these packages you can find on NPM, including this new one called Bitbybit.dev cad-cloud-sdk. So we will talk about this one later. But if you go to npmjs.com, let's do that. And in here you type at bitbybit-dev, hit search. You will see Bitbybit dev base. So this one is on version 1.0.0. Core, OCCT, OCCT worker, Manifold. You will see all of these packages that you also see here, right? So if you want to install these packages in your own websites, what you can do is use a tool that is very convenient, and I will show you in a minute how to do that. So first you have to open up the terminal, then you can go to Bitbybit dev. Let's do this. Here on our website you can scroll down. If you don't want to type anything in your terminal, you can find it. Let's see, where is it? Yeah, here it is. So in order to start quickly with creating an NPM based project, we just hit this button, copy, open up the terminal, and I will say Ctrl V, my project. Let's hit enter. So you see that I typed npx at bitbybit-dev create app, my project. I hit enter. So it asked me to install create app package of Bitbybit, and now I'm presented with this terminal command where I have to choose whether I want front-end application or CAD cloud app, and I do want front-end app for now. Let's hit enter. Let's pick the game engine. So here you see I can pick ThreeJS, BabylonJS, or PlayCanvas. Let's pick, let's say, okay, the ThreeJS then. Let's do that. Here you have to pick Open Cascade Technology Kernels architecture. Let's go for, I don't know, okay, 32 bits is fine. So now the project was created and it says that I have to do these steps. So cd my project, npm install, and npm run dev. Let's do those. So I'll go to cd my project. I'll do npm install. So this will take a while. Okay, it's finished now. And last thing that we need to do is npm run dev. So what happens is now we can open this hello world application. If we go into this location, let's do that. Okay, so this is hello world of Bitbybit, right? It's very basic. It has three shapes, this cube, green one. This was computed by using Manifold geometry kernel. This cube with rounded corners was created by OpenCascade, and this union was created in JSCAD. So this is sort of hello world of bit by bit. Very simple, very basic, right? But if you would go back, you can Control-C this process. So you stop it and then you do ls. You see that we have here index.html, package.json, source directory, where all of the code exists for this project, right? So if you open this folder, my project, with a coding editor like VS Code, you can inspect the source, you can change it, and basically this is your website, right? If you build it, you can deploy it on your own hosting, for example. So if I go to src, you'll see that I have here main.ts, style CSS, and in main.ts you will find all of the source code that is required to initialize BitByBit, ThreeJS, the geometry, and everything that you see in this Hello World application. So what we just did, we went from these npm packages, right? We installed all of these packages with single command that we found on this homepage. In fact, if you go to Learn website, you will find it here as well. This is one of the most common commands that people should use when initializing a bit-by-bit based project, right? It's very helpful and makes setup very easy because it scaffolds the project. You don't need to do that manually. But yeah, the idea is that we install all of these packages if you choose to create a front-end application. In this case, we chose ThreeJS, right? So this npm package was installed. Together with this package, all of the other packages were picked up. If you choose BabylonJS, then we install this one. And if you choose PlayCanvas, then we install PlayCanvas with the rest of the packages, right? So we did not install this one because cad-cloud-sdk is meant for cloud development when you want to develop applications that talk with our server infrastructure. But yeah, for our situation, what we did, we created a website that had only front end, and it only had node modules of bit by bit, and it used that to create 3 types of geometries. So this example was very basic, right? We had cubes in the scene, but if you want to check out some more advanced examples, you can go here into this Learn BitBybit.dev, hit this Learn button, go to npm packages. We were using ThreeJS. Just find this model, for example, parametric model. Go here. Here's the StackBlitz example that also is using the same npm package, except for the fact that it hosts that on StackBlitz. StackBlitz is a coding environment. Okay, so what you see here is basically an application that is also using ThreeJS and is creating this shell structure subdivided into hexagons. And I can just change how many hexagons I have here, and it will recompute. You see that the number of hexagons will change, and you see also the dimensions. So yeah, this is pretty cool, I think. What you have to understand is that bit by bit through OpenCascade geometry kernel is generating this geometry. Also, we provide you tools to create dimensions. So these kinds of CAD experiences can be created. You're not only limited with solids and cubes, as you saw in the Hello World example. And if you want to analyze the source code of this project, you can go here. You see that we have a similar structure that you had when we scaffolded this Hello World example. If you want to understand how geometry was created, check this file, create shape. And here you see things like shapes, face, subdivide to hexagon wires. These are bit by bit functions, right, that we call on OCCT cad-kernel. So I hope this made it a little bit clearer on how this path is used usually. It's important to mention that node modules are usually useful if you are a developer who is not just starting out, who already has some experience in coding. If you're someone who's fresh, probably some different approach is more suitable for you. Although I must say, because it's so easy to set it up, because it's also quite easy to get coding agents nowadays helping you vibe code, I think this path becomes quite easy and relevant even for beginners. But like Bitbybit was set up in a way to allow real beginners to start out, people who don't understand geometry, who don't know how to code. So in those situations, we have this part of the infrastructure, Bitbybit.dev website with Blockly, Rete, and Monaco editors. And we already saw it here. So it's the main website of Bitbybit, where you enter, which is containing those 3 editors, Rete, Blockly, and Monaco. You can start them by clicking these buttons. So Rete, for example, is an editor where you can just code by connecting wires. Let's do shapes, solid, let's create some, H-beam. Let's do that. So this component that we just dropped into the canvas created this geometry, through these parameters like width. So let's do 4, 5, 6, let's increase the thickness to 1, flange thickness. So we created a form, and now if I want, I can also just fillet the corners, similar things that we did. Hide the original, and you see that we now created this nice looking shape with rounded corners. If you want to control variables, you can also use number sliders. So this one will go between 0 and 1, or that's fine. And let's put it on 0.3, connect it to radius. And you see that now the shape became really round. 0.1 was the original, 0.4 will make it almost completely round. And this is how easy it is in Rete to code 3D geometry that is parametric. Looks quite nice. And so these editors that we see here on the map, they help you learn how to code, because all of the algorithms that we have in these NPM packages, they are exposed as these components. So if you go here, you see that this component is OCCT fillet edges. And in fact, if I click on it, we will go to the documentation of OCCT fillets, and you will see also what information I need to provide to it. And here we have shape, radius list, and indexes. And all of these you find here as well. So basically how it works is that Blockly, Rete, and Monaco, they all have access to these NPM packages, and they use those algorithms to create UIs which are user-friendly. And you can then export the scripts that you create and execute them on your website as well via technology called Bitbybit Runners. So in order to learn about Bitbybit Runners, you will need to go here. You will need to just go into Runners, Bitbybit Runner. This is a foundational technology of Bitbybit. But basically, we explain how that works. It's a single JavaScript file that you embed in your website. And when you have it, you can set it up in a way to be able to execute exported scripts from these visual programming editors. So if you want to export this script, you can go here, hit this button, export to runner. You can minify it before you export, but basically this generates JavaScript that you can copy paste to your website, and Bitbybit Runner, that single JavaScript file that I mentioned, you embed it, and it creates possibilities for you to clone this code and run it on the runner. We can look into that here. So Bitbybit Runner has these live examples, and I will go here to alloy wheel read script. Here we have an example that generates a geometry of alloy wheel. So this is more complex script. As you see, there are quite a lot of components, but if I hit recompute, because I don't see this run button here, but basically this script creates a wheel geometry that you see here. So I hide now the script. This is the wheel, okay? And here we have StackBlitz application, again, that imitates your own website that you can deploy on your own infrastructure. And it has exactly the same things, just if you inspect index.html, you will see that it contains this Bitbybit Runner BabylonJS from version 1.0.0. And this is index.html, so this is the single JavaScript that I mentioned in the beginning. And what it does, it allows you to create this script.js where you define runner options. You tell that you want to use Open Cascade geometry kernel, and you copy-paste script from this Rete editor into here. So you see that this is quite a big script because the geometry is quite large, but in general, it creates exactly the same geometry on your own website as you see here in this Rete editor, right? So here we have these visual components that were used to create the geometry. And here we have already the script that runs as JavaScript embedded into this website. What we saw now was runner executing Rete visual script, but it's not limited. The runners are not limited to only that. You can check these examples here. And for this time, maybe we can pick PlayCanvas, another game engine that we integrated. And here in the PlayCanvas full render example, we can go again to the StackBlitz demo, start it, and you see that this time we're using Bitbybit.dev version 1.0.0, and it's Bitbybit PlayCanvas Runner. We have here runner options as we had with the previous example of alloy wheel, but this time we get the runner instance, and you see that the runner, after we say that it should run with these options, it returns bit by bit, bit, camera, scene, app, and PlayCanvas itself. So in this case, we create directional light. We create the model definition. And what it does, it just creates this geometry in bit by bit that looks quite nice, okay? And it renders it in PlayCanvas. So this is, again, a different example of how Bitbybit can be used with another rendering engine. And this is an example where the runner was used just inline. You see that we have here a script tag, and then we begin with our logic in the same index.html page. So one HTML page that contains all of the logic necessary to create these kinds of geometries. Basically, we investigated two variants of how Bitbybit runners can be integrated in your own websites. And you see that here we have two paths. So here we have your scripts, of course. So export visual scripts or use custom JavaScript code, which you can then run on your own website via the Bitbybit runner. And there are four types of runners. It's important to know that. One is for BabylonJS, one is for ThreeJS, one is for PlayCanvas, and another one which doesn't have rendering engine. It only contains the CAD geometry logic in this Bitbybit.dev core. This core runner is the latest one, which I don't have the demo for, but how it works is you can just generate GLTF files through Bitbybit core and render them in any game engine, right? It can even be another type of game engine or import it into the CAD software, for example, and work with GLTF directly there in Blender as an example. Or you can also generate step files and open them in FreeCAD. Maybe you don't always need to render 3D geometry on your browser. You just want to run the computations, right? So the core runner allows you to do that without the overhead of rendering. So this package is the smallest naturally because it doesn't contain any logic for rendering 3D geometry. Yeah, so I think I'm done explaining the runners. These are pretty simple and powerful pieces of infrastructure. And you see here that I'm saying Bitbybit Runners is option 1, embed public preview option 2, npm install is option 3, and the REST API is option 4. I say that these are all optional because they are optional, right? Depending on your use case, you might choose either npm packages or Bitbybit Runners, but probably if you already picked one, you will not be using the runners unless there's something special about your application that needs that. And definitely for the backend, not all apps will require it. I will explain when do you need it, but for now, just know that these options exist for you in the front end, right? So let's discuss the iframe. And the iframe is simply a window to BitBybit.dev itself. You may have seen that BitBybit has projects, and these projects basically have, we can pick this one. So this was created for 1.0.0 release candidate, but all of the projects have these direct preview buttons. And if I hit it, what it does, it will open the full screen experience in the browser. It will take a little bit of time to compute everything. You see here that geometry computations were done. And now we have this cube and this URL to the project that we can put on our own website and render it in our own website. So this approach requires Bitbybit dev platform to be present and available. If it's unavailable, your website will also not show the geometry. Usually our platform is available, luckily, and you can use this approach, but you need an account and you also need to publish these projects. So how you publish the project, we can look here into a few examples. So I have here these pods. If you go and edit the script of these pods, you will see that you have here this Rete editor. I will hit run to just generate the geometry here. So this script created these two pods. And now I can just hit this share script preview. And you see that it will generate me a link to this experience. If you don't see that, that means that your project still needs to be published. And when you publish the project, it becomes public, right? It is being shared on our ecosystem. Other people on the internet can access it and see the source code. So it's important that you understand before publishing that this is the case. And also just read our terms and conditions. Public projects are shared under MIT license. So if you're okay with all of these sort of limitations on the public projects, you can share them. And then basically what you do is you click this button, you create this link to your project, hit Ctrl+C, and then you can even check here. You can generate this embed code IFrame to the project. I will just pick all of that text here, Ctrl+C, go to this PlayCanvas example. Let's start it up. And I will remove everything in here that we used for geometry creation. I will also remove the runner. And now, instead of these two, I will just paste the iframe and we'll hit save. And you see that on the StackBlitz application, now I have two pods that were created from this project, right? This is very simple way to share 3D experiences on your website, on your portfolio. If you create a project, you're a beginner, on Bitbybit.dev, you code it in Visual Scripts without writing TypeScript, and you can then share those experiences with others through your own website by linking to the published project, right? This is very, very simple, but quite powerful, I think. So yeah, we discussed now runners, we discussed the iframe, and we discussed the node modules. All of these are infrastructural pieces for frontend. So the last thing I wanted to discuss is this piece of Bitbybit CAD Cloud, and I want to explain to you a little bit few scenarios when you should consider using it. This is mostly meant for businesses and enterprise customers of Bitbybit, but you should know and be aware of some limitations of the front-end based CAD systems, right? So naturally, when you integrate all of that into your front end, what happens is when your users come to visit your website, their browser will load all of the CAD kernels, all of your 3D algorithms, and all of the logic that is needed to generate geometry, right? Usually, your users will probably have a nice laptop, a desktop, and those are powerful to compute your geometry fast. So now I'm working on Apple Silicon Mac. It runs all of these CAD operations really smoothly, and there's also no network latency involved here because everything happens on the user's machine, right? It's as if they would run desktop application more or less, in the browser, which runs near native speeds because we use WebAssembly compiled kernels. So these are fast and they execute geometry smoothly. But if your users use all devices, mobile phones, and you want to support them, well, this model might hit some bottlenecks, right? Depending on the geometry that you're generating, the larger, the more complex geometry you want to create, the more intense algorithms you develop, the more this architecture will begin to struggle, especially on lower end devices. So if you are smart and you will optimize everything, it will work fine. You can make all kinds of optimizations for the CAD geometry and rendering. But if you hit certain limits of what is possible on the browser, you should consider moving to the backend. Another situation is that because everything runs on the front end, naturally, your logic itself is public to the whole internet, right? This is how front-end systems work. You can open up the browser, you can inspect everything in any website, you can check what kind of JavaScript files are loaded, and it's possible to even read your code of your 3D configurators. So if you're concerned about intellectual property, you should probably also consider moving your algorithms to the cloud, to the backend, where they are not exposed. Another situation where backends become very important is if you want to run computations that take, let's say, 10 minutes, right? So imagine your visitor comes to your website, maybe configuration happens on lighter representation of the geometry. So you can think about it in levels of detail. So let's say the user is interacting in just fast geometry, but it's not maybe very detailed. And then when it's done, it hits finalize, and that process takes 10 minutes, an hour, a day maybe, if you have to generate thousands of parts and components. So this is hypothetical. But of course, it might happen that the process just takes longer than someone would wait in the browser for operation to complete, right? So what you want to do is you want to schedule a task and you want to come back after some time, inspect the results and save them to disk, maybe mail it to someone else. But basically, if you want to run long-lasting computations that take longer than 20 seconds or a minute, you probably also want to look into this approach of using CAD Cloud. The last important thing that I want to mention about the backend is that here you're limited by a single device running the computations, right? So if you want to run the same computation on 10 devices, that's impossible. That's how this system works, right? Your user visits the website, your user is using a single device, and that device will execute the algorithms and it will run them sequentially. Some algorithms will run maybe in few threads, that's possible, but it's not gonna run the same geometry on multiple parallel compute instances, right? With Bitbybit CAD Cloud, that's different. You can ask it to run the same algorithm, maybe with different parameters, maybe with the same parameters in parallel, and depending on your purchased API key type, you get more or less parallel compute instances that you can use at one moment. So how this works, basically you build your backend in whatever language you want, Node.js, Hono for cloud web workers. You can even use .NET, Java, other programming languages and technologies. And you basically interact with Bitbybit CAD Cloud through API key and through REST API, right? So this is a standard approach of how you communicate with third-party servers. So you purchased API key. It's not free, right? This is a paid solution, and it allows you to interact with our Bitbybit CAD Cloud. And if we zoom in here into this part, you will see that our Bitbybit CAD Cloud takes some algorithms from our open source kernels and it integrates them here. The cloud itself is not open, right? It's proprietary, it's closed, and we do that for all kinds of security reasons, of course, but also there's a lot of intellectual property that goes into maintaining and implementing solutions here. You see that we manage the servers on our own infrastructure. So we have here, well, just an indication, of racks, so that it's conceptual. You know that your algorithms are being executed on potentially multiple servers. You don't need to worry about that. You don't need to worry about scaling them. What happens is when you make a request, we create a task, or we queue it. If there are no instances available to compute your request, your task will be put into the queue, and at some point it will be resolved and your backend will receive a result. We also are planning to integrate third-party licensable CAD solutions here, the ones that require us to buy licenses. So, if some third party offers some good solution for CAD, this will allow us to serve customers with those solutions as well through our Bitbybit CAD Cloud. Because usually, you cannot open source third-party licensable software through NPM packages. So here we have some common integration layer, which gets deployed into these servers, and then all of the customers of API keys can use those algorithms. Via Bitbybit CAD Cloud, you can reach all of these same algorithms that you find here in our NPM packages and more, of course. You can also build pipelines. I will demonstrate that soon. But the idea is that you can reach everything within this space via REST API. If you're an enterprise customer, you can also ask us to deploy your custom workloads to these managed servers. We can also help you develop these workloads. So then you get a chance to just use them also via REST API. But these are separate contracts that we would need to enter in order to do that. So here we have a studio, and studio is the website basically. I can just open it up as well. So I opened Studio in incognito mode. If you didn't log in to Bitbybit, you will see it here. It's studio.bitbybit.dev. And here you basically can purchase API keys. You will need to create an account on Bitbybit. And when you do that, you get access to Bitbybit CAD Cloud. So we'll quickly show you how Studio can be used to create pipelines, how it looks like. There's another video where I explain more about it, but basically you can see here how many compute minutes you've used in your quota. You can manage your subscription, you can revoke your API keys, create new ones. So here also within the models, you can generate some 3D models. I demonstrated that batch mode in another video. You can check it out on our YouTube channel. I will show you this time the pipelines, because these are most relevant to you, I think, if you want to interact with our Bitbybit CAD cloud. So for example, when you cannot really deploy your workloads via tenant-based system that I've explained, you can still create computations via the pipelines. So these are simplified but powerful functions that you can combine with one another to create 3D geometry. And all of that is also available to you as a developer of your backend. So our TypeScript SDK is also allowing you to create these pipelines, also REST API, right? So let's investigate a few of these examples that I have here. I will probably create another one, a dedicated video to the pipelines, but what we have here is this translate, union, and fillet. So this pipeline is creating a box, OST shapes solid create box. It translates that box by this translation, right? So 4, 2, 3. And then it unions two shapes. So the result of the first computation with the result of the second one. You see here that we chose these two shapes here. And then we apply the fillet to the result of step 3 union operation, right? Here you see that it's a drop down where you can pick which result to use in your operation, and you just pick the radius. And then what happens is that you can, of course, extend this pipeline if you want to, but for our case, we will just say, okay, it's enough. The only thing that we want to do is we want to say that we want to get step file, compressed one, and GLTF file. So here is also the pipeline in JSON. This is how you would describe the pipeline if you would be writing the JavaScript REST API code, or TypeScript SDK allows you to also use this structure. And when you're done setting up the pipeline, you can hit this execute pipeline button, and I'm redirected to this task. Also, if I go into the tasks, you see that the task is being now processed and, well, or processing, right? It's being computed. You see that it took 7 seconds to start the operation. This is a staging environment, so on production it usually takes a bit faster. But now the result is finished, and we can inspect what has happened, right? So we can preview the GLTF in 3D, or we can download that. We can also download the step file and open that in FreeCAD, for example. But let's just preview this in 3D. And yeah, here you see that we created, right, first one cube, then we translated it, and then we applied the fillet on the corner so it would look as it looks now. This is how pipelines work, and you can do pretty amazing things with pipelines because they also can take custom step files and apply modifications on top of those files. It can output step files and assemblies, right? So you can be quite creative with these pipelines. They are your window to bit by bit. Any algorithm within our ecosystem is available to you. So things like mathematical operations that you use in Rete editor, they're also available for you in the Bitbybit CAD cloud. So if you go to BitBybit.dev, apps, Rete, here is the math category, right? All of these functions are available to you also in these pipelines. And the same can be said about OCCT. So Open Cascade Geometry Kernel. If you just open it up like that, you see that it contains the shapes. So here you see everything within OCCT. We can go into solid. And yeah, I was creating a H-beam profile in the very beginning in Rete editor. Let's do a similar stuff here. So let's also just say that we want GLTF and step, and let's execute this pipeline. So now it's just a single CAD operation that we already used in Rete editor. So what I had was OCCT, shapes, solid, and what we did was this. So this algorithm was executed in Rete to create this shape. And now you will see that, okay, the task has completed, and we can preview it in 3D. And it's the same shape, right? Just saved as GLTF and previewed in this viewer. Yeah, so I think you get the point, right? We can generate geometry, we can compute various kinds of things via the pipelines. We also support map and choice. These are two powerful, possibilities to iterate through a list, for example, and generate multiple geometries, translate them into multiple positions. There are examples of how this works. So cylinders at positions, you can execute that, see how that works. So let's wait for the result. And here it is. So now let's preview. You see that we used map to move 4 cylinders into position. This is quite basic, but yeah, it's also quite powerful if you would write longer pipelines, right? This will be very interesting. Yeah, so let's get back to our diagram. So we just saw how Studio works, right? We used it with the purchased API key. It was in the staging environment, not in production, but the principles are exactly the same. The last thing I want to demo is how you can create an application with TypeScript SDK with this new cad-cloud-sdk npm package, and use it to also create pipelines, but then in your own backend, right? So we will be using a similar approach to these node modules. We will use the npx command to create cad-cloud application for frontend and backend. We will choose Hono SDK as the example, and we will run both the frontend and backend, and they will contain some pipelines that are already ready-made for you. So let's start it. So here I will go back, and we still have this command in the memory. So npm my awesome CAD backend project. So it will create 2 projects, as I mentioned. Let's hit enter. And now instead of front-end app, I will ask to create CAD Cloud app. And here I will choose Hono SDK, or you know what, let's do the Node.js SDK. This is going to be a bit easier to understand for someone who's already familiar with Node.js, as that is a more popular stack. You can also generate .NET application here, funny enough, but you can do that. So let's start with Node.js and SDK. Let's do that. So now you see that it says that we have to go into this app. We need to go into the backend, do npm install and run dev. And we need to also go into the front end in another terminal, do npm install and run dev. I will open this app in Visual Studio Code to make my life a little bit easier and demonstrate you how the scaffolded project looks like. Okay, so I opened the folder that I've just created, and it contains backend and front-end applications. So front-end is a standard front-end written in React. You don't need to care about that too much. What we need to understand is that backend is now using Node.js, and it also installs this Bitbybit.dev cad-cloud SDK. And all of the algorithms in the source code, they contain already code that will talk with our backend, with Bitbybit.dev infrastructure. You will also see here things like .environment, where Bitbybit API URL is set to api.bitbybit.dev, and that's a correct API URL. You see that you can get your API key here. What you need to do, probably we should also scaffold that. You should have git ignore if you will be ignoring something. You should ignore end files so that those would not be committed to your repositories. This project now is not in any Git repo, right? So this might not work, but basically the idea is that here you just enter your actual API key to develop the application, but then on production you need to save it as environment variable in your own server infrastructure where you deploy your application. So if it's, you know, Cloudflare, then it will be some environment variable secret that you create with API key. Basically, for us, I will just set it up with the API key that I have. Okay, so I did that. Another thing that we need to do is go into the terminal and go into the backend. We will install the packages. I will move myself here for now. I also need to create a terminal and go to frontend, and on the frontend I also need to install the packages. So as I mentioned, the frontend is just a React application. Probably it should be deployed, you know, separately if you ever would use this architecture. Let's get started. Let's do npm run dev. So this runs our frontend. And for the backend, we also installed it. We have our API key set up. And now I will just do npm run dev. So the backend runs on localhost 3000 and the frontend runs on this localhost 5173. And you see that this frontend just has models and pipelines, and you can either generate a Dragon cup or you can, you know, use the pipelines that we already have implemented as examples. So let's use the same translate, union, and fillet pipeline that we executed in our studio application. So now it's running the computation and we will soon see the result. And here it is. It's exactly the same geometry as we saw, you know, on our pipelines in the studio. And you can test out more of the pipelines. But what's important to understand, and that is very important, is that this is our custom code. If we go back to this application, you can go here into this backend, check Bitbybit client, and here you will see all of the functions that we're using from the SDK. So first we create Bitbybit client that comes from the package that we installed, right? cad-cloud-sdk, the one that we saw under node modules. And here we have all of the functions that we're using in this application. So let's find the one that creates the pipeline. So translate, union, and fillet pipeline. This is how it looks like. So you create step. You see that everything is typed here. So you cannot create things that are illegal. Like you cannot say that width is a string data. TypeScript SDK makes sure that you're using correctly typed steps in your pipeline. But these are probably familiar to you, right? So we create the box, we translate that, we union it, and we fillet the edges. And this pipeline gets sent to our managed servers. It gets executed there, and we return the result as a step file, GLTF, or simply JSON, right? If you need JSON response. So this is how the Bitbybit CAD Cloud applications can be built, and the front end, you know, is totally separate. It communicates only with this backend. It was built with possibility to render 3D geometry, but yeah, it's quite basic. You can just check how it is set up. I will move myself a bit lower here. Okay, so now we went through most important parts of this architecture, right? We looked into front-end technologies. We checked how the backend can be built that interacts with our managed CAD cloud infrastructure. There's nothing here in this architecture that is somehow unique in terms of architecture, right? This is pretty standard architecture that you will find in any serious application that you build for the web. So the backend, the front end, those are usually used technologies, right? You do need node modules in most of the apps that you build for the web. NPM packages, you install ThreeJS as NPM package, everything goes via those NPM packages, nothing custom here. And of course, the backend that communicates with third-party servers via API keys is a common practice. It's nothing special about it. What I will say is that, of course, in CAD space, this is sometimes quite hard to find solutions which allow you to do 3D computations on the cloud. So I hope that this is a competitive and interesting solution for enterprise customers. And if you're one of them, reach out and we can look how you can use the CAD cloud for your own purposes. Yeah, and if you're someone who just starts out, definitely check out Bitbybit.dev, right? Look how this whole setup can be used to make your websites have 3D experiences that everyone deserves, right? So again, I would like to invite you to read this blog post, check out all of the new things that went into version 1. I hope you enjoyed this tutorial, and I hope it was useful and informative, and you will use it as a reference when navigating this platform. I didn't discuss 3D-Bits app. 3D-Bits app basically is using similar approach. It also got updated, right? Because the runners were updated. Everything sort of boils down to 3D-Bits app for Shopify too. I will probably make a separate video about that. But yeah, this is a main infrastructural piece that was updated. And I think this video is already long enough to just explain these parts of the infrastructure. Again, I hope you enjoyed it, and let's see each other in the next videos. Cheers.